In this video, I want to show you how to solve basic polynomial equations by factoring, something you would typically see in an Algebra 1 course. Well, keep in mind that not every polynomial equation can be solved by factoring, but it is the first thing you should look to do when solving a polynomial equation. In general, you'll start by getting all the terms on one side of the equation and making sure it's equal to 0. Then by factoring the algebraic expression, we can employ the zero property of multiplication to get all the solutions or roots to our equation. I want to start by looking at an example where the algebraic expression on the left is already in factored form. So what we see here is our equation, and it is set equal to 0, and that's what we like to see. And we have 1, 2, 3 unique factors. We started with some algebraic expression and we factored it. So we're kind of picking this problem up about halfway through, and we're just going to go ahead and finish it off. And I want to show you how this zero property of multiplication works. So the 5a is one of the factors, and the 4a minus 7 is one of the factors, and the a plus 5 is one of the factors. And all three of these are being multiplied together to get 0. Well, that means that at least one of these factors, has to be 0. So we're going to employ the zero property of multiplication, which states that if you have a times b and that equals 0, then, either a or b or both have to be 0. So we're going to account for all possibilities, and we're going to go ahead and set each factor equal to 0. And now that I have three basic equations, I'm going to go ahead and solve each one of those independently. So I can divide by 5 here to get the a by itself, and we see, of course, a equals 0. And then here we're going to add 7 to both sides, so we'll have 4a equals 7. And when I go ahead and divide, I'll see that a equals 7/4. And then our last one, we can just subtract 5 to get that a all by itself, and I'll have a equals -5, and that's my third value. So typically what you're going to do then is go ahead and kind of summarize and say a equals 0, 7/4, and -5. And that's how you would write it. You would go ahead and separate each value by a comma, which kind of means or in math. So a equals 0 or 7/4 or -5. And you'll see if we plug these values in, if we plugged a equals 0 in, it would zero out this factor, which then would cancel everything. If we plugged in 7/4, it would zero out this factor, which again would cancel everything. Or if we plugged in -5, it would zero out this factor and again cancel everything out. So these are the three values that will work. I want to take a moment and say something about this greatest common factor that we pulled out. So you notice in this case, the greatest common factor was 5a. And so when we set it equal to 0 and solved, we actually got a equals 0 as one of our solutions. And the reason that happened is because the greatest common factor included a variable. If, however, this a had not been here, and the greatest common factor would have just been 5, then the equation we would have written was 5 equals 0. Well, that's kind of a false equation. This doesn't even make sense. So we wouldn't even bother with it. And that means that this 0 would not be here. So to kind of summarize this a little bit, anytime your greatest common factor has a variable, it will include a 0 as a root. But if the greatest common factor does not have a variable, it will not result in any kind of solution or root. In this example, we have the equation 7n squared plus 14n minus 105 equals 0. So the first thing we notice is that all of our terms are on the left side, and the equation we have is equal to 0. So what we can go ahead and do is factor this left side. And I notice I have a 7 and a 14 and a 105. Well, I know that 7 is the greatest common factor of those three numbers. Let's go ahead and pull a 7 out. So it looks like n squared plus 2n minus 15 equals 0. Okay? And then this is a quadratic trinomial. The leading coefficient is 1. So I'm going to factor this in this form Bring down my greatest common factor. And I'm going to ask myself, what two numbers multiply to make negative 15, but add to make positive 2? Well, 3 and 5 are 2 apart, and they multiply to make 15. So the larger will be positive, so I'll say positive 5 and negative 3. Okay, so I have 1, 2, 3 factors here that I've used, so I'm going to set each one equal to 0. And as we just got done discussing, this 7 equals 0. This is an equation that actually does not contain a variable, and it's a false equation, so we're just going to go ahead and ignore that. So remember, anytime your greatest common factor does not include a variable, you can just ignore that. So here we'll subtract 5 from both sides and get n equals negative 5. Here we'll add 3 to both sides and we'll get n equals 3. So I can say n equals negative 5 or 3. And those will be the two solutions or roots for this equation. So I'd go ahead and encourage you to plug those in, make sure that works, and you'll see that these are the two solutions for this equation. And we went ahead and found them by factoring. In this example, what we see here is that we kind of have variables all over the place, and we even need to distribute to kind of get rid of these parentheses. So this example will kind of have everything involved. So let's first distribute. So we'll have 2m to the 4th plus 4m, and that's going to equal m cubed plus 8m squared. Well, okay, the next step, remember, is to make sure that all of our terms are on one side of the equation. So it looks like 2m to the 4th, this m to the 4th is our highest degree term, and he's positive on the left side. So I'm going to go ahead and move everything to the left side, because you'll find out that if your highest degree term is positive, then it makes the factoring process a little bit easier. So let's go ahead and push these two terms on the left side. So 2m to the 4th, and I'm going to go ahead and write things in standard form, so descending order of powers. So minus m cubed minus 8m squared plus 4m, and that's going to equal 0. Okay, so I have my equal 0 and all my terms over here. So the first thing to factor this is to look for a greatest common factor. And it looks like all the terms have m's, and the smallest one is a 1. So let's go ahead and take out that m to the first. So I'll have 2m cubed minus m squared minus 8m plus 4, and that equals 0. So let's go ahead and use factor by grouping, because I notice I have 4 terms here. So we'll continue the factoring process. So the first pair looks like I can pull an m squared out, and what I have left is 2m minus 1, and make sure to get this minus 1 in here. Even though the m squared is the greatest common factor, when we divide you'll still have that minus 1. So the next term is negative 8m plus 4, so we'll go ahead and take this negative out, and we'll also take a 4 out, so we'll end up with 2m minus 1. Okay, well these two leftover expressions are the same, which that's fantastic, so we can go ahead and take them and factor them out. So I have that 2m minus 1, and then the m squared minus 4. Ooh, well this m squared minus 4 looks like the difference of two perfect squares. So let's go ahead and set up that difference of squares factorization. The square root of m squared is m, and the square root of 4 is 2. So we'll say m minus 2 and m plus 2. So now we have this algebraic expression in fully factored form, and we have 1, 2, 3, 4 unique factors here that are all being multiplied together to give me 0. So let's go ahead and use that 0 property of multiplication and set each factor equal to 0, and then we'll solve all of these equations independently. Well, the greatest common factor here had a variable, so we will include 0 as one of the solutions. And here we have 2m minus 1 equals 0, so I'll show you a little shortcut here. So you're going to add 1 and then divide by 2. So anytime you have the binomial in this form, you're going to change the sign. This is the numerator, this is the denominator. So you'll end up with m equals, change the sign, so instead of negative it'll be positive, and then this is the numerator, and this is the denominator. And that's just kind of a short little way to do it, because really you're going to add 1 and divide by 2 anyway, so you get the 1/2. But it's kind of a shortcut, so you don't have to do all that work. So the next one, we add 2 to both sides, and the last one we subtract 2 from both sides. So it looks like here we have all 4 of our answers. So I go ahead and write it this way: m equals 0, or 1/2, or plus or minus 2. So here are the solutions then for this original equation, and we solved it by factoring. So that's kind of just a general, brief introduction of how to solve these types of equations by factoring. And again, it's something you'll see in an Algebra 1 class, so this isn't going to get too crazy yet.